Okay. If you face any issue, let me share the screen and let's start the class. Okay. So from today onwards, we will be actually working on the directly on the analog part. Okay. So this is a CMOS fabrication with module 2 actually. So we will be working on the CMOS fabrication. So we will understand what is CMOS fabrication, CMOS fabrication is done properly. This all thing, couple of things we will come to know so that we can get some overview of the fabrication part in detail. Okay. So now let me come here in this side. So are you able to see the screen? So
No,
this
sir.
is CMOS.
No, sir,
No,
can't see, sir.
not sir. Is it now visible?
No, sir.
No, sir.
No.
No, sir. The voice is also breaking, so for me.
One second. Is it now working?
No, sir, your screen can't, you can't see your screen, sir, and your voice is breaking much more.
Okay. Let me do one thing. Wait, let me do one thing. Well, hello. Is it now visible?
Yes, sir.
Yes, sir.
Okay. Excuse me. Okay. So we will be starting today's CMOS fabrication. So okay. So before starting CMOS fabrication, so our outline will be actually introduction, CMOS devices. What is CMOS devices? Then CMOS technology. Then CMOS logic structures, CMOS sequential circuit, CMOS regular structure. So this will be our actual outline for this whole thing. Okay. Coming to the CMOS technology, when we will come to the CMOS technology actually. Okay. So we'll come to CMOS technology in which lithography will be there, like lithography, physical structure, CMOS fabrication sequence, yields, what is called design rules, other process, like many other processes are there, small. So advanced CMOS process enhancement and technology scaling, in which one thing is not added till now in this one. What is like how to prepare the wafers. So how to prepare the wafer, that I will add it, it is not added here. So I will add and tell you how to prepare the wafers, how it is been prepared, what is Krolaski method, that is not added here. With that is a separate PPT that I will add, I will combine in this one only, so it will be easier for you to understand. It will start from the before this one, before this CMOS technology only, that wafer fabrication, that preparation will be also there. Okay. So can you guys tell me what is CMOS fabrication part? Any idea you have, you guys? So what is CMOS fabrication? How it is done? How it is not done? Like anything? I think someone is waiting outside. Hello? Can you tell me what is related to CMOS fabrication? Anything? Hello? Hello? Nageshwar, Nanda, Akila, Nilani, you can tell me what is CMOS fabrication? What are its significance? All these things? Any idea?
No idea from my side, sir.
Nilani, Nanda, Akila, you.
The combination of PMOS and NMOS is called CMOS, sir.
No, that is fine. That is very basic question answer. But like what you understand by fabrication, can you tell some steps? Can you tell some hierarchy of the fabrication? Why fabrication? How it is done? Like kind of thing. These all things.
No, sir.
No, sir.
Oh, okay, okay, okay. So let's see. So there will be a chip. Okay, so in that one what happened in CMOS technology, I tell you, an integrated electro circuit is an electronic network fabricated in a single piece of semiconductor material. Okay, so this is actually what CMOS technology is. Semiconductor surface is subject to various processing steps. These are the one very basic summarized view. So which is impurity and other materials added with the specific geometrical patterns. The fabrication steps are sequenced to form this three-dimensional region. So let me tell you, let me do it in the paint. It will be easy for you to understand. Okay. So let me take the pencil and let you understand. So when from a sand, from a piece of sand, so this is a suppose a sand is there. Okay, so this thing is put it is heated at high what I say, at a high melting point. The high heat has been prepared. Okay, extreme heat. Extreme heat is given. I will give you the PPT for this also. So extreme heat is given for the sand. What is when it is put it in a crucible? When it is put in a crucible and after the heat is there and the impurity is added to this one, the sand is being converted into a shape like this one. Okay, like this kind of shape it is being converted. Okay, this is called this silicon actually. Okay, the silicon crystals are being created like with extreme heat and impurity, adding impurities. Okay, then what happened? Then thin nano blades are there. Okay, so thin nano blades are there which is responsible for, one second, what happened? Okay, one second. Okay, so thin nano blades are there which cuts these silicon things in very precise manner. Okay, like thin wafers will be come out from these things, like it will cut in this. So this kind of small wafer will come out. Okay, so this kind of wafer will go, circular wafer will come out. Okay, so these wafers are very thin, and on this wafer only the lithography actually happens. So in this kind of wafer when you come across, you will able to see hundred and thousands of chips depending upon the size is being fabricated in a single this kind of in single this kind of wafer. Thousands or hundred of that these chips have been fabricated. So one each of these things are one single chip. Okay, many chips will be there. So then again they will cut into pieces and then they will be like this kind of chip will be there. The silicon thing, then it will be put on a plastic packaging. This kind of packaging it is being put and it's being connected with some interconnection connectors. So it is being connected like this and then it has been sealed and it is actually sent to you guys for your applications. Okay, So this is what actually a basic of a fabrication is. Okay, now let me go to the PPT part. So this is how the fabrication looks like. So if what you are seeing here, let me enlarge it. What you are seeing here actually, that is the chip. This is a chip die actually. This is called a die. This is a die actually. This thing is a die. So in this one, what happens? So in this one, it is colored die. Okay, so you are seeing this block, this simple thing is a part of that chip only, which is cut out from that big circular wafer. Okay, in this one, multiple thousands and hundreds of transistors are placed in this one. So these are being used. Okay, so lithography. So what is lithography actually? Lithography process which is used to transfer patterns to each layer of the IC. Lithography is a, these are some definitions. So main will come from this part. Actually, we will come from this part. So what is lithography? The lithography is a process used to transfer patterns to each layer of the IC. Like I can tell you, in lithography, the things are like that. A light is passed, a laser light is passed with a very precise wavelength. Okay, so that is passed through the masks. So if I tell you, suppose this is a wafer placed at below this one. Okay, and a lithography machine is from the top is coming. Okay, so okay, and there will be a mask will be there, kind of this kind of thing. That the mask is that now what you have designed in the cadence, that is called a mask. Analog layout is also called mask design also. Okay, analog layout is also called mask design. I think someone is there. Okay, so this thing is actually also called mask design also. So if you come to here and see, so in, oh, 1 second, let me get this pen, white color pen. Okay, so analog layout is also called as mask design also. Okay, so what happened, this mask is designed by you guys. Okay, or analog layout engineer, in which you will see some kind of pattern. Suppose this kind of pattern is need to be placed on the wafer. Okay, so this kind of pattern will be there, and other part will be hidden. Okay, so other parts will be hidden. Normally other parts will be hidden. So if you see here, when the light will pass from this level, so when the light will pass from this level, okay, when the light will pass from this level, you will able to see the wafer part actually. In this wafer part, you will see that this thing will get fabricated actually. You will see that this thing will get fabricated immediately. This thing will get fabricated over this. If you see this part, this thing will get fabricated. Okay, this thing will get this pattern which is there in the top will get fabricated at this wafer part. Okay, so this is the what the use of lithography machine actually. The lithography machine actually tries to fabricate this thing over this one. Okay, so wherever this is actually the design, this is actually the mask actually. This is what you guys actually made in an analog layout. So these how things, the wafer is being fabricated using the lithography machine, and some other parts are also, other steps are also there. Many steps are there. Lithography is one of the steps in this one. Okay, lithography sequence step: designer drawing the layer pattern on the layout editor, which is a you guys analog layout engineer. Okay, so you are design drawing the layer pattern in a layout editor. Silicon foundry mask generation from the layer pattern in the design database. The fabrication plant generate the files, mask files from your designs, and then transfer the mask pattern into the wafer surface. In this wafer surface, this mask is been transferred using this kind of process. So process the wafer to physical pattern each layer of the, so each layer by layer it will be done, like NVL is there, metal layer is there, oxide layer, many layers are there. Those are done in different steps. Okay, to fabric, when one material will be like oxide material is given, we want a cutout of the oxide mask, so we will put that part on that part of the oxide, then we will put one again, one other layer, other part will be put on that one, like metal part, and metal material will be there, then again that kind of mask will be there. So like this kind of design is being put on the from the lithography machine. Okay, so this is the lithography thing. Actually, I will discuss in details also. So basic sequence, if you see here, if you come here and try to see this one, in photoresist coating, okay, if you see this SiO2, okay, SiO2, if you see, this is the substrate actually, this one is the substrate, and this is the photoresist material, because those kind of thing in this, on this top, this, what is this white background is being shaded na, this is called the photoresist material. Okay, if you see here in this one, the exposure, this is the opaque part, the black one is the opaque part, and this, what is the mask actually is the design, ultraviolet light which passes from the top and underexposed, this is the underexposed actually. Okay, so which is not exposed with a photoresist mask, this part need to be get fabricated. So now what happened, the light got put on top of this one, after everything is done, then it has been etched out, the chemical has been put on this one, and this see, the pattern photoresist will now serve as an etching mask to the, for the SiO2. So the SiO2 then etched has been done, this part got removed properly, this part is solid, this part got soft due to the light falling on top of that, and then the chemical removed that soft part. What happened, a kind of a trench, like a depth kind of structure has been created. You can see this kind of structure has been created. So this is what it is required to do. Okay, so this is how actually the overall process happen in the time of lithography or in the fabrication part. So this is actually the normal thing. Okay, and the lithography. So if you see, go by going more details, you will able to see much more detailed steps. So let me show you the lithography part again. So let me show you the detailed process of the CMOS fabrication. We will come back to detailed fabrication lithography step by step. Let us first go to the lithography actually. Let me first go to the lithography. What is fabrication part starting from here? Okay. So the CMOS fabrication is starting from this part. Okay, so actually the step one, it is like step, those are detailed part. So this is like step one, step two, step three, how they will be done. Okay. So in the CMOS fabrication, first step, pure silicon is extracted by melting the sand and converted into cylindrical shape, which is then cut into thin disc type structure called wafers. I already explained this one. This kind of material is being taken out from the sands, and then this kind of structure is being made using the cutters, like very thin cutters are there. So those things cut this kind of silicon structure to form this kind of thin wafers. Okay. Now the CMOS, in the step two, this is the step one. So step one itself is a big task. So I will explain the step one step by step, how this thing is being prepared, what is Krolaski method, what is Krolaski's machine. Okay, this thing I will prepare. What is that crucible? What is the heat furnace, blast furnace is there? How this has been put in that one? How the impurities is there? This itself, step one will be a roughly a 1 hour thing, half an hour topic. Okay, discussion topic. So first we will discuss some overview. Then we will discuss some, in depth the CMOS fabrication. Okay, then we will get to know all the things in details. So this is the step one. Step one is creating the pure creating this kind of wafers. So how the wafers is created in detail we will discuss. First, just get to know. So these are the wafers. It has been created. Normal this wafer is created using from this kind of big size cylindrical crystals. Okay, how these crystals are made in detail we will discuss. Then we come to the step 2. Now the substrate, how it has been prepared. Start with p-type substrate. Like we generally start with p-type substrate only. Okay, in which holes are majority and electrons are minority carriers in this. You need to remember, holes are majority and electrons are minority carriers in the p-type substrate. Okay, you have to remember this one. If someone asks you, you have to explain this one. Holes are majority and the electrons are minority carriers, in which impurities are added using doping. What impurity added, we will tell you. So this substrate is being created on that wafer disk. On this kind of wafer disk, this kind of substrate is being created. Okay. So these substrate are being created using the P substrate. Okay, the substrate material using the doping. Then step 3 comes. On the top of this substrate, last time we did a substrate, on this one, a oxidation will be there, exposing exposing to high, the substrate thing will be exposed to high purity oxygen and hydrogen approx 1000 degrees centigrade in the oxidation furnace. Okay, when this material is being placed inside a oxidation furnace, okay, with high purity oxygen hydrogen approx of 1000 degrees Celsius in oxidation furnace, it been converted to SiO2, silicon dioxide, SiO2. This thing of deposits get deposited over this kind of metal, get deposited over this substrate. Okay, this SiO2 got deposited over this substrate. You have to explain the interviewer how these steps are there. Okay, like no one will ask you how the silicons are made, how the silicon crystals are. You just to tell the silicon is melted. In that silicon, after melting the silicon thing, that crystal is drawn. Those crystals is been cut down into thin wafers using the nano blades. Then these wafers are taken, in which the substrate is being made. Like substrate is being made using the dopings, where p-type substrate has holes are minority and electrons are minority carriers, in which impurities are added using doping, using the doping process. Okay, then in the step 3, SiO2 layer get deposited over the P substrate. How it is done? The substrate is being exposed to high purity oxygen and hydrogen with approx 1000 degrees Celsius in the oxidation furnace, due to which SiO2 gets deposited over the P substrate. Okay. After in this one, in the step 4, you will see photoresist coating is been done. SiO2 is been done like this. Okay. After the SiO2 is done, the photoresist material is being given on top of, because we need to create a trench, like we need to create shapes on this one. This SiO2, we will creating some kind of shapes like this. Okay, so for that one, the photoresist material is been uh, given on this top of this one. Okay, photoresist is a light sensitive organic polymer. It gets softens when UV exposed to UV lights. Okay, when from see, now what happens, suppose this is a mask, you have put a light from the top. Okay, this is a kind of a shape is there in this one. Okay, and a light coming from the top. When the light coming from other, this part in the mask, it is opaque, it is hidden, doesn't have any path for the light to get travel. Okay, from here the light will pass. When the light pass from this shape, it will fall on this photoresist material. When this photoresist material will fall, okay, this kind of shape, this part only up till this part, the light, due to the light falling, UV light, this photoresist material will become soft, and other part it will become hard. It was already hard, it remains as it is. But when the light fall, this part will get soft due to this kind of shape is there. If you see, this kind of shape is there, due to this shape the light passed and over this one, and this got soft. Okay, now what will happen, we will go to this part. Suppose the masking, as it is told here, what I just explained here, it said masking. Then what will happen, in this one the light fall, then we will remove this photoresist material from this area. After removing this one, you will see a structure like this will get created over the SiO2 material. It will get a, this place will be blank completely. Okay, so this is how the shapes are being created. So we will discuss these shapes again here also. So we will be able to discuss these shapes again. Let me clean this part. Okay, or let it be. Now again, this again what I discussed, it again been discussed here. Masking, expose foot, like step by step you have to take. Step 4 we discussed like photoresist mask. Okay, photoresist mask has been put on top of this one. Okay, on the SiO2 material, photoresist mask. Then the masking will come, like the mask will be there, like the mask what you have been prepared, those designs, like expose photoresist through N-well mask. Suppose we are using we have to create an N-well structure, so we will put an N-well mask. Okay, so N-well mask is given here. UV light is passing from all the mask layer, but here is the shape. Actually what will happen, light will pass from this area, which will come up till this level, which will come up till this level actually. Okay, actually up till this level this will come. Okay, so this is how the mask is being put on the top and the light is passed. Okay, then what will happen, the remove of the photoresist. The photoresist are removed by treating the wafer with acidic or basic solution. As the acid has been put on this one, what happened, the part of that photoresist which was exposed to the light due to that mask shape, it got which got softened, it has been removed by a acidic or basic solution. You can see a cutout like structure is in this one. This is a cutout like structure. Okay, then the SiO2 you can see. Now in the step 7 you will see the acid etching. Now you will just see the SiO2 is selectively removed from the area of wafer that are not covered by photoresist. Okay, by using hydrofluoric acid. Now what is the thing? You will see this kind of structure is being created. This photoresist doesn't get react with the hydrofluoric acid. I have to create shape in this one. Okay, this SiO2. So this will not get this photoresist material is not reacted with, not reactable with hydrofluoric acid. It, but the SiO2 will get reacted. What happened, the shape where the mask has been cut out like this. Okay, in cut out like this, in this part what happened, the hydrofluoric acid have been pour on that part, due to which the SiO2 got reacted with the hydrofluoric acid, and the shape like the photoresist mask got out of this one. Okay, okay, so the this part, so if you see this SiO2 part, this overall part got removed automatically. Okay, so this is how SiO2 is like SiO2 part is removed and a kind of a shape is being created. So this is the step 7 you have to say. So you have to read this one. I will explain this again also. Don't worry. Then this photoresist material is being removed. Now you can see this top part, this one got removed. It got removed actually, photoresist material. When it is being removed from this part, you will see this shape is left over. Okay, this shape is left over. This SiO2, a trench like structure, a depth. You can see a depth like structure is being there. Okay, after the removal of the photoresist mask. Now, what will the next step? Ninth step, formation of N-well. Now, the cutout has been made over the SiO2. Now, N-well is formed using with diffusion or ion implantation. With ion implantation or diffusion, what is diffusion? I will tell you. So, and ion implantation also. So, N-well is formed using the process called diffusion or ion implantation. So with the ion implantation, the diffusion has been formed over this one. The N-well is now formed over this trench part. Over this trench part, the N-well triangular structure has been formed on the substrate. Okay. Now, this up till here, the N-well is created. You can see how it has been done. So up till here, can you guys confirm it is clear, or I need to explain the these parts again? Hello, hello, hello.
Yes, sir. Yes, sir.
Yes,
I
sir.
understand.
Can you repeat again?
No, sir.
It is clear.
Yes,
Yes,
sir.
sir.
Okay, okay, okay. So see, in this what I am showing you, step 1, step 2, step 3, step 4. This is only for the interview. This is not for the explanation. Explanation PPT is much more in detail. Each and like what is ion implantation, what is oxidation, what is metallization. These all things will come in more depth. Okay, each of the topics will cover only 4 or 5 PPTs. So it will be a huge PPT actually. Okay, so these are just basic steps which you can tell in the time of to the interviewer. Okay, this step 1, this one, step 2, this one, this all things you will able to tell. So this is the thing why I am first telling you this one, then I will go to the detailed part. Okay, so that you don't get confused. So the overall fabrication happens in this way. In that one, each topic has a different explanation. So up till here, NVL is created for us. Now we will go to step 10, removal of the SiO2. So now the SiO2 got removed the hydrofluoric acid. So we already use the hydrofluoric acid again. So hydrofluoric acid reacts with the SiO2. Earlier it was having this kind of photoresist mask on top of this one. If you see the photoresist mask one there, okay. So due to which this part got removed only, but the other part was there. If you see the last one, so now photoresist mask have been removed. Now the top part, this one got removed, remaining only this part. Okay, this part is remaining. So now again, HF has been poured on this part, SiO2. Now it has also been removed. Okay, silicon dioxide. This also been got removed. Now you will see a proper clear structure. You can see in this part, you can see a proper clear structure at this level. Okay, now you can see only the end well is left off over the substrate. Okay, so after this step, the end well is done. End well has been created properly, SiO2 is removed, and this substrate is now we can go to the next step for creating the other shapes. Now what will happen, a polysilicon deposition is been made again here. Okay, polysilicon, because the gates have to be made. Okay, so polysilicon material has been given on this one. So polysilicon material, 1 second. Okay. Polysilicon material, last SiO2 was there, now the polysilicon thin gate oxide. Okay, so this kind of material has been put on the again top of this one. So deposit very thin layer of gate oxide using CVD, chemical vapor deposition process. This is the other point of explanation. Excuse me, we will explain it. So CVD process, using CVD process, this material has been put on top of this one, a thin gate oxide. On top of this one, a polysilicon material is been put on this one. If you see here, okay. Now, after this has been made in the step 11, we can go to the next step, step 12, in which now the end diffusion and the diffusion can be created. Now the same process in end diffusion forms NMOS structure, then well contacts. Okay, now what happened after this structure is done, if you see here, if you see your thin gate oxide is already in this part. Okay, in the top of this one, a polysilicon material has been added. After, if you see in this part, okay, so thin gate oxide is there, then on polysilicon structure has been added properly. Then what happened, then same kind of masking, that falling of the light from the top using the mask, that again have been done using that photoresist material. Same step every time. When you have to create a step, you have to follow that step, putting a mask on top of that one, on that photoresist material, light will pass, When the light is passed, that gets softened and it will be removed using the acid or basic solution. When then done, that SiO2 and the photoresist material will get removed, and this kind of structure again will get created. Okay, you will see this kind of structure again will get created. So this is the same process repeat again, but just we are repeating this step again and again to create different shapes over that particular p substrate wafer. Okay, now the step 13 comes. N diffusion, dopants are fused on or ion implanted. So this is the ion implanted part is different. So like this again, the n plus regions are created like this. Okay, if you see n plus region is created here, then the gates are created, source and drain is created. This is an N well actually here. This is a P type. This part is PMOS and this part is NMOS. Okay, so this how these things are being created. And then the oxide, if you see strip of oxide, the silicon dioxide, okay, these have been stripped off using again the hydrofluoric acid, HF. Okay, the hydrofluoric acid is been stripped off. So now this kind of structure again got created properly. Now in the step 14, if you come, you will come to see similar set of steps from P plus diffusion region for PMOS source and drain substrate contact. So if you see the PMOS drain and source, the substrate contact should be there. If you have seen in the layout, you have seen in the top of that metal part, if you see, let me show you. If you have seen in that layout part, you have seen this kind of structure was there on that devices, this kind of blue metal structure, and some couple of contacts were there, like this kind of contacts were there. If you remember, I've shown you yesterday also, this kind of contact is there on top of this one. Okay, this kind of contact is there on that one, and then the layers are, then the layers are, red layers are there, oxide layer, polysilicon layer, other layers are there. Okay, so this is the contact what is actually been put here. This contact is called the substrate contact. This yeah, white colors are there now. This is called substrate contact. Okay, substrate contact. So these are the substrate contact which have been put on this one to get connected properly with the source, drain and gate. After in the 40 step 14, contact cuts. So these contact cuts which are required for the substrate contact, these have been created. The device are the wire are to be wired together, cover the chip with thick field oxide. Each oxide where contact cuts are needed. So each contact cuts, they will fill this thing with oxide material, whole thing, and then they will put that kind of the contact masks. That contact mask will each those parts, and using the HF hydrofluoric acid, again those things will be removed and photoresist will be removed. You will see on that one the contacts, small contacts will be made like this, like wherever the contacts have been there, those things will be made properly like this, like this will be made properly. Okay, so these contacts has been placed all over the layers. Okay, so this is how it has been created. Now if you come to step 16, the last step, which is the metallization. Metallization, sputter over the aluminium over the whole wafer. Okay, then pattern to remove excess material, leaving wires. Now what happened here, in the top of the whole wafer, you will see in the top of the whole wafer, all the shapes are already there. Okay, if you tell me, let me show you. All the shapes are like this. Okay, if you see, all the shapes are like this kind of thing. Okay, all the shapes are like this available in this one. Okay, now I have to make some connections kind of thing. So okay, let me do it for you. Okay, so let me do it properly. So now to connect them, now we have to connect them. Okay, so the connections are between, suppose, this part and this part. Okay, like this kind of connection is there. So what they will do, they will put this whole metal over this wafer. They'll put whole metal things over this wafer part. Aluminium they will put, and then what they will put, they will put a photoresist material on top of this one. After this whole material has been given on this part, then what they will do, they will put a photoresist material. Suppose consider the red color as a photoresist material again. Okay, this photoresist material again, consider this one. and this one, when the light will fall from the top, actually it will create the shape. Now let me remove. Now it will create a shape over this one. The shape will be like kind of this thing. Okay, the shape will be like this thing. Okay, now let me remove it and let me show you again. That shape will be get created as the older process, what I show you, that the shape will get created, and then using a HF, hydrofluoric acid, those shapes, those extra things will be removed, and the photoresist will be removed. So the shape should be like this. Okay, this kind of shape should be there. Okay, this kind of shape should be there. So due to that aluminium sputtering of the aluminium there, the excess metal is removed, and the living wire which is got fabricated, which is got came from the light, actually that mask that is got part left up and other got removed. Okay, so this is how the metals connections are done. So this is what called metal. And you can see here, on top of the whole part is covered with metal, thick filled metal oxide. Also, okay, so metal has been put a spar over this one, so to make this whole thing proper. So this is how a normal in the interview you have to explain the whole fabrication process. You can explain this in, I think, 5 minutes, 4 5 minutes. You can explain the 16 steps easily. So these 16 steps are essential, crucial part of your interview. You have to know each and every step. What is oxidation, what is metallization, what is Krolaski method, everything you have to ask, you know. But interview will look how you can explain the whole fabrication step in a very compact manner. So these are the 16 steps you can explain easily to the interviewer in your interview, that these are all the things are done. This how this process is being done made. So this is how we can do a CMOS fabrication. Okay, now if you explain them, then from that part they might ask you, okay, so we came across the fabrication. Now, can you tell me what is ion implantation, or what is oxidation, or what is Krolaski method? Then you have to explain that particular method in detail. So this is the this thing. This have been this thing. So now they can ask you what is Krolaski method. You have to explain the Krolaski method in detail. So these are the things. Those are some different bifurcation. We will be understanding this all fabrications again when we will be discussing those steps, those topics in detail. Again, this thing will come. Like CMOS fabrication is not much small. Okay, so this is only to make you get habituated with the fabrication hierarchy. This is not actual fabrication. Is actual fabrication is very big. If you see, actual fabrication is very big. It's a roughly of 67 page slides material. This is okay. So we will be able to explain this one in details. Give me 1 second, please. Me 1 second. Okay, hello. Okay, so this is the much more in-depth detail of the each and every topics actually if you come across, like what is lithography, how etching process is done, how every detailed process, how the undercuts are done in this one. If you see, it is more detailed structure is there. What is CVD process, what is the how it is been explained properly, what is fabrication sequence, everything will be detailed in much more depth way. Okay, and but that is only to explain you guys what is the fabrication. Like it's like a trailer, the whole movie is left off. Okay, like in that, this is the trailer part only. Okay, so movie will start from tomorrow onwards. Just kidding. So this is the overall overview. So how you have to just read these things when you will go to interview. Last 14 15 slides you have to read for you, but before that one is much more in depth detail, and some topics will be added in this one. So like in detail topic explanations. Okay, so these all things will be added, and then it will be explained to you in a proper sequence. So this is the fabrication steps actually. So from tomorrow onwards we will be starting that in depth, like what is lithography in depth, what is etching, what is Krolowski methods, what is ion implantation, what is doping, what is CVD, what is chemical mechanical polishing. There are many steps, metallization, there are many such steps are like this which are big, which can be explained. Then what is AFM, atomic force microscope, then ACM. ACM is also there. Okay, so ACM is a kind of a microscope only. So we will be explaining all these things essential for the overall fabrication thing. Some couple of pictorial images will be there from the fab labs. We will be adding, actually this work is going on for the CMOS PPT. So the CMOS PPT, some other things will be couple of things added in this part. Okay, so this is what actually the overview of a CMOS fabrication part. This is not actually a complete fabrication. This is an overview. This 10-14 slides which I told explained you today, just to make you familiar with the fabrication, so that you can be comfortable when learning each other. Okay, that topic came. Okay, this will we be doing again here. Okay, so this slide, this PPT slide I will share with you today, and not the whole one, this 10-14 slides what we have studied today, that I will share you today, so that you guys can be habituated with this overall thing, so that you can be comfortable, so that to understand what. So before coming tomorrow, please read these 10-14 slides and try to understand using this watching this video again to overview, so that you do not get uncomfortable when I will explain the overall in detailed fabrication steps. Okay, so in this today's session, is there any doubt for you guys? You can ask me. Hello.
No, sir, fine.
Is it clear to you, Ganesh?
Yes, sir, yes, sir.
Akila,
Yes, sir.
Yes.
Nageshwar,
Yes, sir.
Nidani,
Yes, sir.
like it is clear to you, right? Okay, so I will be sharing you the PPT by tomorrow, so that you can guys get to know, understand the overall concept of the whole thing. So that please read this PPT once before coming to tomorrow's class. Okay, so it will be helpful for you to understand the overview of the fabrication. Then we will able to discuss each and every steps. In this PPT, I will be highlighting those points which will be explaining in much more detail. Those will be highlighted with the bold letters. Okay, so that we will be able to discuss in much more detail. Those things will be discussed properly. Okay.
Okay, sir.
Okay, so I think this much is there. So if you have any questions, queries, or doubts, you guys can ask me.
Sir, can we have one extra day for decoder, sir? Can we submit on Thursday?
I have already given the Thursday, na, in the
Yes.
group. I have given only the Thursday in the group. Okay.
Thursday?
No, yeah, Thursday already I told her, Thursday morning.
Okay, okay, okay. I can see that.
I have given the already given in the group. So any other queries? Like, have you started decoder, Ganesh?
Not yet, sir. I'm going to start tomorrow.
Okay, okay, okay. So you do not need to make any NAND gate NOR gate again and again. You already have the pre-built NAND gate NOR gate. You already have built, I think so, you guys.
Yes, sir. Yes, sir. Yes, sir. I have it.
Use them, use those only to build this thing. Okay,
Yes,
got
sir.
it now?
Yes, sir. I am going to that one.
Yes, do that one only. Do not need to make those things again. You just
Okay,
need
sir.
to use those previous things to build them again.
Okay,
Okay.
sir. Okay, sir.
Okay, then we can end the session today here itself only. So I will send you the PPT either by today or tomorrow morning. Just have a casual read over the PPT so that you can just guys remember what have been taught today and just understand the try to get some overview by listening the video recording again. Okay, that will be I think good enough to go.
Sir, can you please be just a second? After stopping of the recording, I will stop. I will talk, sir.
Okay, 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 okay. Okay, okay, we can stop the recording, no issue.